Hey everybody, it's Mrs. Casil and welcome to a demonstration in slow motion of what is happening in your lab today. So as you set up your lab, your first task was to get that cup of water brimming. And I mean brimming, so full that you think maybe it will overflow. So you can see here I'm doing just that, and you can actually see that the surface of the water is curved upwards. So this has to do with the intermolecular forces between the water molecules here. They're attracted to one another, so they pull on one another, and they create what we commonly call surface tension. So as I'm adding more water here, it's increasing the volume in the cup, but those forces among the molecules hold them to each other with a stronger force than the force of gravity. So there they are. I now have a cup that has this positive bubble over the top. You can even see little droplets bounce in it. That's just so cool. So here's the thing to think about. In a second, I'm going to get my string lined up around my cup here, and I'm going to pull on the string. The string is touching the yellow cup. It is going to pull the cup across the table. So great, duh, we've seen that before. I know you've pulled things with strings. I know you've pulled things across a table before. But let's think about what we learned today about Newton's first law, the law of inertia. The law of inertia says objects in motion stay in motion, and objects at rest stay at rest unless they're acted on by an outside force. So here we have a situation where we're going to apply an unbalanced external force, an unbalanced force, and we're going to change the state of motion of this cup. It is at rest. I'm going to apply a force to it, and it will accelerate in the direction of my applied force. What about the water that's brimming right over the top edge? What's going to push or pull on that water? And that's the crux of this demonstration. As I pull, the cup pushes on the water inside, but there's nothing pushing on the water that's brimming above. So it stays at rest, meaning that once the cup is moved, it falls down. That's why the water tends to spill behind the cup, opposite motion.